Hello everyone, today I am going to discuss on the topic Opcode fetch machine cycle, and I am going to discuss only the basics about this topic, and I am going to start by taking an example of command MOV, which is move command, and having hex code or opcode for a fetch, and let us assume that it is stored at some address in our memory, that is 2005H. So let me give you the overview how the microprocessor and memory works to fetch some opcode from the memory location. So here, as shown in the figure, we have microprocessor and memory which have many locations, and out of these many locations we have stored our data at 2005H. Our microprocessor will send the address to the memory by using the address bus, and memory will send the data back to the microprocessor stored at that location. But before sending the data to the microprocessor, our microprocessor will send a signal, that is read bar signal, which is active low signal, which will tell our memory that yes, that it needs to read the data at particular location. After receiving that signal, our memory will put the data on the data bus and send it back to the microprocessor. In our microprocessor, that is 8085, we have total 16 address buses. In other microprocessor or in advanced microprocessor, you have many more address buses, like 32 address buses. But since we are discussing about the 8085, so we have only 16 address buses here, out of which 8 address buses are higher order address bus, and the rest 8 address buses are multiplex address bus. The upper address buses carry only the upper address of any location. For example, in 2005, it will carry the 20 of the location, whereas our multiplex address bus is used to carry lower address, that is 05 of location 2005, as well as the data back to the microprocessor. But we have other terms also which we will use in our timing diagram. The first one is clock, which helps to regulate the speed of execution of instruction in the microprocessor and also helps to synchronize the different components of the microprocessor. The next is read bar. Here the bar will come as it is the active low read control signal. It will tell the memory that yes, microprocessor needs to read the data. Other one is input output memory bar. Here also bar will come. This used for the memory location, and it is also a active low signal, as here bar is there. The other is ALE or address latch enable signal, which is an important signal to multiplex our address buses. So how this multiplexing is done in our microprocessor, I will show you in the next slide. Here, as you can see in the diagram, we have our microprocessor 8085, and I have shown here the address buses. We have total 8 address buses to carry the upper address or higher order address of the location, that is 20 in our 2005 location. And it will work for the 3T cycles in the timing diagram, whereas the lower address buses will carry the O5s of the location 2005, and will work for the first T cycle only, that is 1T cycle only. For the rest 2T cycle, it will get freed because it is need to be used as the data bus by our memory, by our microprocessor, because it needs to carry the data back to the microprocessor. So how it is done? For the first cycle, it carry the lower address, and after this cycle, it will pass that lower address to our latch, that is our lower address, will stored in this latch. So how it is stored? After 1T cycle, our microprocessor will send the ALE signal which will help to store this lower address in the latch. So after 1T cycle, it will get freed and ready to get the data on it so that it can be transferred to the microprocessor. So in the final, our memory will get the location uh, half from the higher order address bus and half from the latch itself, not from the address bus. So once our uh, once our memory is ready to read that signal, then it will put the data back on the data bus, that is 4FH, and then our microprocessor will receive the data. So now you have the idea how the opcode fetch machine cycle will work. So let us draw the timing diagram. So here in the diagram I have shown you the timing diagram in which we have a clock signal which uh, which are four in total, and which will go from low to higher, and so on. The next is address buses A15 to A8, which will carry the higher order address only, as I told you before also, for the 3T cycle. And the fourth cycle, the address will be unspecified, or during this time some execution will be occurring, and our the next AD7 to AD0 will carry the lower order memory address for the first T cycle only. And then our microprocessor will send the ALE signal, and then signal will tell the address bus that you need to store this lower address in the latch. So during this time, our the process of storing that lower address in the latch will occur, and then these are the status signal that it will tell us that data need to be read from the memory. So it is active low, so this signal will remain 0, the rest signal S1 and S0 will remain 1. The read bar signal, at first it will remain high. Since it is active low signal, it will work when the signal is low. During this period, it will become low and tell the memory that yes, you need to read the data. So during this time, our opcode will be read from the memory, and after reading that opcode 4fh, our memory will get that yes, this is the data that our microprocessor needs. So it will put that data on the data bus and send it back to the microprocessor. So during this T4 cycle is the unspecified cycle. We don't know that during this cycle the execution will occur or it's sent back to, or our data is going back to the microprocessor that it needs. And also most of our command use only 3T cycle for the 4T cycle for the execution. There is very rare case that when it will use the 6T cycle for the opcode fetching, but for most of the command we have only 40 cycles only. So that's all for this topic. I hope you get that easily. Thank you so much. Stay safe, stay healthy.